Dhirendra is a software engineering manager at Google with 2 decades of experience in building complex distributed systems. And Tejas is a senior engineer at Netflix, specializing in machine learning and recognized as the Tech 40 Under 40 awardee. Today, they are here with us to talk about their book, discuss the impact of AI on system design, reflect on their experiences in big tech, and offer career advice for those looking to transition into system design. So, very warm welcome to you both, Dhirendra and Tejas. It's a pleasure to have you with us.
Thank you.
Thank you. Thank you, Divya.
Okay, to start with, Dhirendra, could you begin by sharing what inspired you to write System Design Guide for Software Professionals? What key concepts or gaps did you aim to address with this book?
Yeah, absolutely. I have been in the industry, as you said, for more than 2 decades, and I've worked at few startups, big companies doing very complex, large-scale system designs. And I started teaching system design about 7, 8 years back. But the reasons were two big reasons. Number one, I wanted to give back to the community. And the second one was I was being selfish, that moving to management was taking me away from the core technology. And this gave me an opportunity to sort of be still in touch with technology. So I always thought I should write this book, but I could never, gather the courage and time to really get started. So when Packt reached out to me for this, I think they indirectly reached out to me, meaning one of my mentors actually recommended my name. I said, yeah, that's going to be a good opportunity. But I also insisted that Pact should find a co-author. I didn't want to go through, the whole pain alone. So, of course, Tejas was recommended and we clicked together and has been a great author to work with in this project. So, yeah, I think the main reason we wanted to write this book was basically to go deeper into the system design concepts, but also think about preparing senior candidates for system design interviews, because it's a very crucial part of the interview which decides your leveling. Your acceptance is one thing, but also your leveling. So that was our intent when we wrote the book.
Okay, wonderful. Thank you, Dhirendra. And now, Tejas, could you tell us what motivated and inspired you?
Sure. First of all, thank you to Dhirendra for his kind words and for being such a gracious co-author for this book. I couldn't have asked for a better support partner and better person to brainstorm ideas with. And as part of this, I've only become good friends with Dhirendra. So first of all, I'm very thankful for that. And I think that, like Dhirendra, I've been in the industry. I've worked at companies like Box and Netflix, where I have seen the challenges that happen in software systems when they scale, when the number of users, the number of applications scale, how these systems, if not architected correctly, can fail in unobvious ways. Also, I've seen a lot of senior engineers actually, fail to bridge the gap of designing scalable systems. So that was the initial motivation to explore the field of system design. And I also felt like, system design is an afterthought. People always think about system design when it comes to just interviewing. But I felt like, and both Dhirendra and I discussed this, that is not how we wanted to structure content for this book. It was not meant solely for interviewing, but it was meant as a reference guide on telling you why certain architectures and design choices were made, and how to think about designing systems that you take beyond just the interview stage to actual implementation in scalable organizations. So I think demystifying some of the distributed system principles is what our aim was through our book, rather than just providing like a checklist of here are 10 questions and 10 answers you go with. And we went into details with concepts. We could have done much more and gone into more concepts, but we felt like this was a great foundational piece to build on top of. So that was the motivation of, writing a book, yet another book on system designs.
Okay, brilliant. Thank you for that, Tejas. I'm going to continue with you. we're sort of going to shift into talking about what everyone wants to know, AI in system design and the impacts it's going to have. So in your book, you've laid down a foundational principles for system design, like you've said. Now, how do you see these principles interfacing with the rapid advancements in AI, such as AI-driven automation and operations and system design?
That's a great question and a very pertinent one in the times we live in, because everything is all about AI agents and different types of tools that are coming out. But I feel like the idea or the foundational principles of system design, like scalability, reliability, efficiency, these are remarkably timeless concepts, even as we see AI that rises to prominence. In fact, I feel like the rise of AI reinforces the importance of these foundational elements. And like companies like Netflix and Box also have increasingly used this concept of AI ops, which is leveraging AI for operational efficiencies and for scale. So we use intelligent systems that automate tasks like scalability, auto scaling, anomaly detection, self-healing. And I think that AI, interestingly, can be used to help build more scalable systems. That is one end of the puzzle. The other end of the puzzle is when you have a bunch of AI systems or AI agents, how will you scale them? How will you design systems for them? And I feel like that's an ongoing challenge that the industry is facing. Recently, we've seen that like OpenAI came up with their Ghibli-like portraits. And on the second day itself, Sam Altman tweeted that, please pause creating images because our GPUs are melting. Now that is, you can think of it like a system design problem, because this means that the way architecture is done for parallelization of these models, there is an opportunity to design better systems there. And I feel like they don't necessarily set foot on each other, but they actually complement each other well. But I would love to hear, Dhirendra's thoughts on this as well.
Yes, Dhirendra.
Yeah, absolutely. I think that completely is, in my mind as well. Like, if you talk about system design principles are, very foundational. So, and they remain foundational, even, if the AI world, we talk about automating different workloads, thinking about, scalability, reliability, efficiency, all these things, if you really see it bases itself onto a good architectural design. If that is not there, you can't do anything with AI. AI will optimize something, AI will recommend something, AI will augment something, but then the core architecture has to be solid. And that core architectural thinking it cannot be, easily substituted. So that is why we need a very good command on system design principles. So I think whatever AI would do, it will play a very crucial role in a lot of things, right? Load balancing, if you will, self-healing infrastructure, how to you fine-tune the auto scaling. It's, in my previous team, I was working in very different kind of auto scaling, which is very good predictive before even all this AI wave came. So it is very useful. But then if the architecture is not well thought out, even if the AI driven automation is there, it will optimize certain things, but it will be very brittle. So that's very crucial. So I really see AI as a powerful tool in the system design, but we need to make sure the fundamentals, the foundational is very strong and scalable, where AI can come and play its magic. So I don't see a foundational thing going anywhere. It emphasizes, in fact, exposes more gaps in system design. If there are gaps, AI will optimize something else and you will have a very spaghetti kind of non-optimized, you optimize something else. So let me put it that way.
Okay, got it. Thank you for those insights, both of you. Now, Dhirendra, I'm going to continue with you as we move on to our next segment, where we want to pick both your brains about your experiences in big tech. Both of you work in companies like Netflix and Google. So, Dhirendra, what are the current most pertinent challenges in system design you see in the industry today?
Yeah. I think a couple of challenges which I see, during my tenure at, Google, Yahoo, and few other companies is scalability under unpredictable load, right? When you have global users accessing different services 24/7, designing systems that can handle unpredictable spikes without over provisioning. It's still a challenge. I mean, you can really do optimization around predicting, what will be the usage, but certain spikes can render the system unusable. I think that's still a problem. And the other thing I feel is the tussle between the data consistency and performance and availability trade-offs, right? That is also another challenge. It is optimized to a good extent, but we still time and again, we talk about this heavily in system design interviews that, hey, how would you do the trade-off? Trade-offs are a big key and big challenge still. The other thing which I see is the security and privacy at scale. Now, security and privacy at small, scale, you can solve by doing a lot of things, but at scale and with ever increasing threats, designing a secure and privacy compliant systems and still performing efficiently, it is tricky. It requires balancing encryption, access controls, compliance, keeping performance in mind. It's not trivial. So that I feel is, another challenge which I see. And of course, the AI brings its own challenges. We are still sort of grappling with it, understanding it. How do we really, coexist with it? So that's a challenge which is still evolving. Yeah, those are the thoughts on top of my mind.
Okay, so Tejas, would you like to add to that?
Yeah, I would second actually everything that Dhirendra mentioned, because these are the kind of challenges I've seen at companies like Box and Netflix as well, where you have unpredictable loads. A very good example is when we had our live streaming, the event, and we were predicting the number of users to be X, but actually the number of users are more than 3X on our platform. That meant that, some of our systems were not able to scale, not because we did not design it correctly, but because we had assumptions about our dependencies. And I think in complex distributed systems, when you do not own all the pieces, you rely on your partners and on dependencies, unpredictable load can tear some systems at the seam. And that is precisely what happens when you build large scale complex systems. Another challenge is Netflix primarily is, for example, has a bunch of microservices, lots of them. So when things go wrong, you want to know which service called which other service in what order, with what parameters. Yes, there are tools that do it out there, but at the scale at which Netflix operates and the amount of asynchronous code that we run, sometimes stitching together what really happened is often challenging. And this is typically a problem with distributed systems. So there is a lot of observability challenges at scale that we deal with. And because we have the number of users that we have, and because we create the number of movies we do, cost efficiency at scale becomes another interesting part of our challenges that we face at scale. So designing systems that are cost efficient still are fast enough for the users, still give a great, compelling experience, but also are extensible. Those are some of the core things that companies like Netflix and Box have to deal with. And again, privacy and security of the data, of with AI coming into the picture, how can we balance the need to evolve and be creative with the security and privacy guarantees that we traditionally offered? Those are again interesting challenges that we see.
Right. Okay, so Tejas, to add on to that, in this sort of complex and challenging sort of landscape, what are some best practices big tech applies to approach scalability and system robustness, according to
Yes,
you?
that's a great question, because at Netflix, we, for example, and I've seen it at other big tech companies as well. The first thing is designing for failure. So we assume like the worst case scenarios while designing it, and our mindset is that everything will fail eventually. This was actually the genesis of the Chaos Monkey project that Netflix is very popular in the system design circuit that Netflix came up with. What we want to do is make sure that even when services go down, we have operational resilience and we have good ability to have a backup responses for those services. That is the core principle of designing our scalable systems. And to make sure that that happens, we have continuous automation, monitoring, observability, and also auto scaling. I would say that some of the best practices would involve, let's say, automating routine jobs, having observability and monitoring at scale, designing for failure, and also having the right amount of caching and boundary conditions. So being very explicit that, your current architecture can support up to X number of users or up to X number of requests. I think most systems fail when there are faulty assumptions made about this. So those will spell out, like, I would say these are some of the best practices I've seen. And finally, rollouts. I think that is a very crucial piece. A very good example is in Netflix, when we come up with a new algorithm or a new recommendation, let's say, we wouldn't roll it out to the entire world at the same time. We would actually identify cohorts of folks that we want to roll it out to first, get feedback, see what is working, what is not working, and then roll it out to more people. The same concept applies to other aspects of software as well, where you would want to define availability zones, you would want to define smaller subset of instances that you want to roll out your change to, and then, expand it to other regions. Those are some of the best practices I've seen with system design at scale.
Okay. Dhirendra, would you like to add your views on this?
Yeah. It was very interesting that, Netflix was the company which talked about this Chaos Monkey, and it was very interesting when I first heard about it. But truly so, if you design for failure or plan for failure, you assume that failure is got to happen, and then you see how can you deal with that failure rather than making your system perfect and no failure would happen. That is like, I remember at Yahoo, somebody put the code up and they said, oh, this corner case, that would happen 1 in a million. It's not a big deal. And then my chief architect would say, 1 in a million? That happens every hour. What do you mean? So, so scale is a very different beast. You talk about a basic system, it'll work fine. You throw scale at it and all your assumptions, all your planning, everything goes to the drain. And you need to really think about how do you really build system which is fault tolerant, horizontally scalable. Some failure happens, it will recover soon. I think that is the premise of any highly scalable system. You can't make basic assumptions that, oh, this won't happen, that won't happen. Every small thing can happen. So I think that is one thing. And as Tejas was talking about, I think observability, proactive monitoring. I think in my engineers also, I encourage them to think about not launching, but landing. And launching is like a feature which would you have completed the code and you wash your hands off. Like, I'm done with the code and the build system will take care of it and will get deployed. We talk about landing as to how the feature or the project is being adopted. What are the operational challenges? How is it, performing while in production with different load? How are you able to really make sure that it is not a big pain maintaining it, right? Or running it operationally. So that's a big thing which I encourage my team to really think about it, just not write up the code and done with it. And the other things which we make sure we think about is automating different things, which they just talked about. Very simple things, make sure they're automated, they're not really left to manual attention. Even if those alerts which you put up, with different metrics, the threshold reaches and there is a alert firing, those have to be actionable and something can be done with infrastructure as a code, like in Terraform and Kubernetes, where you set the expected state and things will evolve. Those completely make sense and you should totally rely upon that and make sure those are tested well, right? Those are the things I remember, in my experience, some of the things we think about when the scale hits your system.
Okay. Thank you for those rich insights. And we are sort of going to piggyback on the same real world rich experience you bring as we move on to the next section, which is about career advice for aspiring, system designers. So Dhirendra, I'm going to start with you again. During the interviews you conduct for hiring within system design roles, what do you look for in candidates? What are some of the most important questions you ask and why?
Yeah. So system design questions are not very relevant for really beginners, college, graduates, freshers. It's not very relevant. For them, it's more like, coding, algorithms, those are more pivotal. But after a certain point, maybe, 3, 4, 5 years of experience, you start interviewing and people now start going into the system design. So as a hiring manager, I've hired so many people, interviewed so many. I have lost count. So when we ask system design roles, I primarily look for candidates who really demonstrate the structured thinking, right? How are you approaching a problem, an unknown problem? You might have heard about it. And again, system design is very different than coding or algorithmic problem. Algorithmic problem might have one or two optimized solution, but system design is like, it's a can of worms. Like, you can take it any corner and have multiple options. You can put in constraints, you can put in artificial constraints also to really see how the candidate thinks. So it's very important to master the art of communication, thinking about how do you structure your approach, scalability awareness, which we just talked about, resilience, all these things you want to be able to understand. And then you want to break down complex problems. That is one of the skills which we measure. At the more senior you go, the more ambiguous problem I'll ask. And I'll rely upon them to really drive the conversation and be able to think about the trade-offs. If they make a choice, why did they make a choice? Because it's very easy to make a choice between good and bad. It's very tough to make a choice between good and good. And that's what senior engineers deal with every day. It's not like, it's very obvious to rule out a bad design, but what about good and good? Which one would you choose, right? So those are some of the things. And then about the questions, I of course, can't share the exact set of questions, but as I said, like, I think any system design question, popular questions like, WhatsApp design and so on and so forth, the popular ones, Uber design, you can, as an interviewer, they can really make multiple questions out of it. I think there are some of the deep dive opportunities which they can go in, popular ones, but also anybody could throw a little twist. And I have my favorite sort of nook and corners. I can get the candidate, put in a corner and think in those constraints. And that is how I start measuring how creatively they can think, how they can use whatever they know to solve this particular problem, which we just talked about. And I also explore their past projects, asking about the trade-offs they really practically did, the failure handling they did, the lessons they have learned, So bottom line is I'm looking for engineers who can design scalable, resilient systems by making some practical decisions under real world conditions. It's not like all the time thinking about theoretical things, but put different perspectives in terms of operational ease, maintainability, right? Cost factor. All these things are, I'm looking for those examples and those nuggets, how smartly you are. You should not be coming to my company and then making your first mistakes. I'm also looking for you have made enough mistakes in your past career that you learned from those and come and exhibit here.
Yeah,
Well,
makes complete sense. Okay. So Tejas, we'd love to hear your views on this. Any, insider info you can share or just best practices.
Yeah. So first of all, completely agree with all the points that Dhirendra mentioned around the fact that structured thinking, how you approach the problem and how you measure trade-offs is a very crucial and critical skill that is required in day-to-day life. And that is a system design interview is a reflection of what you would end up doing working at a company. So I think that's a good reflection of the candidate. But I also, one thing I like to do is I'd like to keep it conversational, where I like to, have them challenge me and some of my beliefs in the sense that they can ask me, how many users am I designing this for? Or, what are some of the must-haves, good-to-haves, and not necessary things to build for this particular interview? I think them asking the questions is very crucial part of system design because that is what happens in the real world. So I intentionally keep the questions pretty vague and I wait for the candidates to, whenever I interview, some candidates, I wait for them to ask me questions so that they can right size the problem. It also gives me a great opportunity to look at or to evaluate what is the right size for this person. Like, what do they think they can size and design for in the next 45 minutes or so? If they go too broad, then I know that they may not go deep enough into some topics and their trade-offs, we will need to discuss them. But if they keep it too narrow, then there is an opportunity to go really deep into some of the trade-off decisions that they've made. I feel like folks come up with a structure there. They come up with functional requirements, but I really like to like dig deeper into design choices. A good example is, when they come up with a system design and let's say they're using a database, I would quickly interject and say, do you think you want to use a SQL database or a NoSQL database? Why pick one over the other? And this gives me a great insight into how they think about comparisons and which to pick when. And then I kind of get deeper into, okay, let's say I have 10 times more users. Which choice is the better one according to you, or does it not matter? When will it matter? So I think those are some of the in the moment questions that give me a good peek into how they think about systems, scalability, reliability. And some of my favorite questions are around consistency, like eventually consistent or not. And I think that I've seen a lot of folks sort of have a unclear picture of how consistency, availability, and partition tolerance, the famous CAP theorems work. So I like to dig into that when I'm looking for folks in system design. I think those are some of the areas that I can highlight, but most of it aligns with what Dhirendra also mentioned.
Okay, so a quick follow-up to that, Tejas. What are the most common areas where you see candidates struggle, and what advice would you give them?
Yes. So I think the first one, I kind of briefly alluded to it, is the way the candidates think about right sizing the problem. Or, when a system design problem is shared, they directly jump into trying to solve it and build diagrams and block diagrams and stuff. But I feel like the first 5 or 10 minutes should be more about asking questions and making sure that they have the right set of requirements, both functional and non-functional. That may not always be clear. So just confirming those and being explicit about the boundary conditions of your system are places where I've seen a lot of candidates falter. That's number one. Number two is I've seen a lot of convoluted conversations and thinking. So they may at one point be designing one part of the system and suddenly jump into the other. This has to do with a lack of structured breaking down the bigger complex problem into simpler pieces that Dhirendra was referring to. And I've seen that a lot of senior engineers also, they instead of having a coherent story or coming up with a reasonable architecture first, which is simple, which works, and then solving for different parts of the problem, they will just come up and get into the weeds in one particular aspect and totally forget or lose track of the other aspects. I've seen over engineering done sometimes in some areas, and I feel like those are great opportunities for folks to differentiate themselves from the crowd by actually being focused on building with simple components and getting into complexities after you have a bare bones working solution.
Okay, and Dhirendra, would you like to add to that?
Yeah, I think, Tejas, thanks for calling this out. I think truly the biggest thing which I feel is people just don't clarify the question enough, scope it down for a 45 minutes interview, and they start jumping on. They see some familiarity and they start jumping on designing everything. And many a times in real life also, unless you're clear about designing, what are you designing? You'll design something else. Bottom line is that, right? So I think it's very crucial to really clarify what the problem is and scope it down, not really wildly design whatever is coming to your mind, but condense it and scope it down and confirm with the interviewer and then get on the problem, because the next whatever 40 minutes you'll spend will be on that problem. So make sure that you clarify. I think that is number one. And rightly pointed out by Tejas. The other issue which I feel is, like we were talking about the consistency, the CAP theorem Tejas was talking about. I think it is crucial. I think most of as you grow senior, more and more, it is about non-functional requirements. You throw scale at it. How does consistency, availability play with each other? What are the nuances there? Not entire system may not be, eventually consistent or strongly consistent. It may be parts and bits and pieces of it. Some feature is highly consistent, the other feature may not be. So understanding those gradations, those nuances is something which is not very clear to candidates, and they often falter there and they get confused. Once you interject them, hey, how about this? Do you think it should be highly consistent or not? They generally don't have a clear picture. I think that they should really go to the core of understanding it. The other, I think, a big thing which I really look for in a lot of senior folks is their reasoning of the trade-offs. As I pointed out earlier, they need to be able to tell me that why are they choosing. And for all we know, if there's a choice A and choice B, both are equally good, would work. Rather than choosing anything random, rather than choosing something they're familiar with, I want them to articulate why did they choose one over the other. And for all we know, it may be slightly incorrect. I don't mind that. I am looking for a reasoning. What is your reason behind it? And I may have a counter reasoning. That's all right. I think a very important thing is to have a reason. Why did you choose A over B? And I think a couple of other two things which I feel sometimes, interviewees don't take care of is time management. A lot of people get so excited and they are just running around, and it could be because they didn't scope the problem well, or they went too deep into something. They may be doing a complex, calculations, which sometimes is not even needed, and they go into this big mathematical calculations. But what they mess up is finally the time management. And at the end, they may not have enough time to really work on the core piece, which was very crucial. And the interviewer is still puzzled that, I didn't even get enough signal because, the candidate wasted a lot of time. So my advice is just, practice and do a lot of mock interviews and time yourself so that your sequence, or at least in your head, you understand you're spending a little bit too much time, and later it might bite you back. And the other thing which I've observed, that sometimes I am giving some hint to the interviewee that, can we move on, or can you take this? Or I'm giving some hint, and it's very crucial to listen to the hint, because most interviewers want to select you, right? But when you don't pay attention to those small hints, then I'm at loss to be able to really judge or be able to evaluate you in a particular area, because I'm giving you the hint. Okay, let's move on. Let's talk. Why don't you talk about that? But if you're very adamant, no, I want to solve this, then I lost the opportunity to even observe how would you think in this scenario. So I think those two things come to my mind in terms of, quick tips, which I would love to give: time management, and the other is listen to the small hints which the interviewer is giving you.
Okay, that was some brilliant advice, and also encouraging when you said that most interviewers want to select you. So thank you for that. But Dhirendra, beyond the job interviews that you conduct, why should software professionals invest in learning about system design? How does this knowledge impact their career development and capability as engineers?
Yeah, excellent question. I think a lot of times people visit system design only when they are interviewing, and which is right. You should definitely brush up and make sure you're really everything is on your fingertips and fresh in your mind. Totally makes sense. But also understanding these system design problems, the concepts, the fundamentals will come in many ways rescue you to, for your promotion, for your career growth, the way you talk about systems, the way you evaluate different designs, the way you write your designs, everything, your deeper expertise in system design really helps you to shine. And these are like, not very, I mean, once you have cracked the interview, you kind of know, but also when you are sort of revisiting or understanding them, it keeps you very abreast of all the changes, first of all, happening. It keeps fresh in your mind that you can ask pertinent questions, right? You can make more informed technical decisions, whether it's, choosing a library or an API or debugging some issue. Everywhere, I think system design really provides a basic framework to understand, hey, what is the trade-off, what we can make here, which would be very effective in our scenario, right? And also system design is like, Tejas was talking about conversation. I think it's all about how do you present your ideas, how do you present your thoughts. That's also another thing that you can communicate effectively through this technical communication, very crucial. Also, as you grow senior, you will be doing a lot of strategic planning, and you would not, if you don't understand system design well, your estimates will be completely random. Like you cannot really, it'd probably be a guess, not even a guesstimate. Forget about the swag, right? Which is a little scientific or a little broken down by real facts. You will not be able to, because you don't understand system design well. So given a problem, you'll just take a wild guess. Okay, it'll take a quarter. How, why, what are the components there? Unless you understand system design, it'll be very hard. And again, I think all these things amount to your career. You want to be in a career where you're in demand, you are getting promoted, you are valued, you are performing above and beyond expectations. How would you do that in a technical role, in a senior role, if you don't understand the system design to the core? So I think totally you should, really brush up, really understand, really go deeper into system design.
Okay. Thank you for that, Dhirendra. Tejas, would you like to add to that?
Yeah, I completely agree with all the points that Dhirendra mentioned here regarding system design being sort of a way of life if you have to grow your career and for you to continue to provide value to your organization. The way I look at it is very similar to the way I look at, math in general. Or let's say, people say, hey, I studied the Pythagoras theorem growing up. Where do I use it? And I feel like the idea is that it's not that you use a Pythagoras theorem or not. It's the fact that learning that or being accustomed to that taught your brain cells the way to think about situations. In the same way, system design tells you to think about first principles or think in terms of first principles, think about foundations. Some of the things that, the world will see 10, 20 years from now have not yet been built. And if those will be built, when they are built, if you have a solid grasp of system design, if you have an understanding of the fundamentals, and if you come with that mindset, you will be best positioned to build those systems and to scale those systems. We are in an interesting era where, we are trying to figure out how the work profiles of engineers, individual contributors, managers, and others will evolve when we have a lot of AI agents taking over the world. And it is even more important to be aware of system design, because I feel like you will enhance your career. You will also become the go-to person when these agents have to scale and do more things than what they are currently doing. So we are at an interesting cusp where technology is evolving, but some of the principles will stay true and will be timeless. So I think that's why it's very important beyond just your interviewing stage to invest in system design as something that you learn and you use every day. Also, in many companies, the differentiating factor in seniority is not how complex code you can write, but rather how simply you can understand and express complex systems. Some of the most senior engineers will actually simplify complex systems, will break it down into systems that can scale individually, and will be able to communicate that in a clearer manner. I think when you work with people that are not aware of system design, you will understand the way that they're explaining systems is also very complex. So it's a very good measure of seniority as well as you grow into your company, like what Dhirendra mentioned.
Okay, that's wonderful. And, talking about preparing for the future with the evolution of tech, looking back on the first edition of your book, Tejas, are there any topic areas or new topics that you would plan to include if you wrote a second edition in the context of this changing tech landscape?
Yeah, that's a great question, and I think Dhirendra and I had a discussion around this as well a while ago. That you know, so much is changing. There's so much more that we could have written, but then it could have become multiple volumes of that book, and that will be the intention. We are, and I think both of us have alluded to this here, that we are at an interesting time where we see a lot of systems evolving, changing. Just recently, I was heads down into the MCP, which is the Model Context Protocol, which is a way for AI systems like ChatGPT and others to talk to data sources, let's say Stripe or Slack or some other systems that are out there. So, these are some of the interesting, nuanced, and newer technologies that, we probably did not get a chance to put into our book. So, when you think about all these AI and ML systems, how does system design evolve with the introduction of AI and ML? That's a very, very big area of opportunity to design systems in. That's number one. Number two, I feel like a lot of focus was on the foundational aspects of system design, but there are equally important aspects that we could not cover in our first edition, like observability. Monitoring and observability that we've alluded to in our conversation today, that these are some of the challenges that big tech faces. So getting into those aspects in system design. And finally, we talked about, designing for the cloud and building distributed systems, but there are a lot of toolings that are available to help people with system design. For example, there are infrastructure as code is a very big area where you can write scripts that will try to bring up your entire cloud infrastructure, your entire security and privacy, primitives that you need. And I think we were not able to spend a lot of time in the book on some of these core aspects of system design as well. And I would love to hear what Dhirendra's thoughts are on this as well.
Yeah, Tejas, I think AI definitely, you said it very correctly. I think AI is very, very crucial, and we need to really see how AI, interfaces with system design, and we could definitely write that. The other thing I think we were discussing the other day also about the data privacy and security considerations in a distributed system. Many a times I've seen we sort of brush it under the rug. We'll have some IAM system, talking about the roles and access and attributes based control and stuff like that. But I think it is crucial now with increasing regulations and sophisticated threats. I think a more comprehensive section on sort of designing secure and privacy preserving sort of systems, it's very important. So that's one thing I felt we could write more on. The other thing I really feel, reading about this, Ghibli images and what happened, I think there is a whole, in the last year also, this whole uprise and the AI war, which is going on with the Gen AI stuff. I think there is a good scope of thinking system design, not only in terms of sort of software systems, but thinking about a little beyond that, meaning talking about some sustainability, some green software, and really thinking about bringing in the element of, are we wasting a lot of resources just for this pretty entertainment, right? What is going on? Can we optimize that? I almost feel that there is a layer of optimization we could build by sort of reusing some of the things and not really going back to the hardware to melt them, as Sam Altman shared. So I think that is another thing which I feel like, how can we build more energy efficient, and we could put some thoughts around it. Of course, I'm sure the folks at NVIDIA and AMD and all these folks who are designing chips are they understand that, but also I think there would be a section which will be increasingly more important now, that you can't just hog on to all the energy resources and to do a simple thing. How can we optimize that? So I feel that is also another consideration we could put up.
Okay. Thank you for that. I think all of us will be really looking forward to your next edition and to working with you on that. But for now, for those watching, do check out the first edition of System Design Guide for Software Professionals for more practical real-world insights. The link to the book is provided in the description below. Thank you for these very deep insights that you shared with us, Dhirendra and Tejas, and for taking the time out today to speak with us. It's been an absolute pleasure.
Thank you.
Thank you so much. Thank you.